Hello everyone. In this video we are going to see a problem on a single line diagram. Let us consider a problem. Draw the single line diagram of a generating station having the following equipments. Okay, they had asked to draw a single line diagram with the following requirements. And those conditions are we are having an incoming lines, okay, it's plural, incoming lines 110 kV 50 hertz. Whatever in the bracket is nothing but the quantities that we are going to draw. Two number of incoming lines with 110 kV 50 hertz. Okay, the number in the bracket represents quantity, and then outgoing lines 110 kV 50 hertz, one outgoing line, 66 kV 50 hertz, one outgoing line, 11 kV 50 hertz, one outgoing line, which means we are having three outgoing lines. In that, one is 110 kV, another one is 66 kV, and one more is 11 kV. Okay, and we are having a transformer. Okay, transformers. One is 15 MVA, 110 bar 66 kV. You can see it here. It has a three-phase transformer. Star delta, primary is star and secondary is delta. Quantity is 2. We're having two transformers. After that, one more transformer, 10 MVA, 110 bar 11 kV, three phase, star bar star, primary star, secondary star. Quantity is 1 transformer, and one more is 3 MVA, 11 bar 400 kV, 11 bar 400 kV. Sorry, it's 3 MVA, 11 bar 400 volt. It is not 400 kV, it is 400 volt. Star bar star 1. And after that they have also mentioned the bus bar. Okay, these are the rare cases that they mentioned bus bar. Sometimes they doesn't mention the bus bar and you people need to design them. Bus bar is 110 kV, 2 bus bar, 66 kV 1, 11 kV 1, 400 volt 1. Okay, these are all the conditions. Now we are going to draw the line diagram for these inputs. First thing is first is incoming line with 110 kV, two incoming lines. Okay, let us consider this one. We are going to draw incoming lines. Since it is first one, we are going to draw a draft of the single line diagram. First is incoming line. Since the quantity is 2, we are going to draw two lines, two straight lines. One is 110 kV 50 hertz, and the second one is also 110 kV 50 hertz. Okay, we draw two incoming lines, and second one is outgoing line. Okay, we'll keep it at the end, okay, so that it would be helpful for us. Outgoing lines. After that we are having transformers. You can see we are having transformers and the bus bars. Let us start with the bus bar. Since here we are having a bus bar, 110 kV bus bar is 2 quantity. So mark 2 110 kV bus bars. To 110 kV bus bar attached to 110 kV incoming line. Okay, since the voltages are similar, we are going to draw the bus bar. After the bus bar, you can see The next bus bar are 66 kV and 11 kV and 400 volt. These voltages doesn't match up with our incoming lines, so we'll keep it later. Okay, after the bus bar, let us see what are the other voltages that match up with 110 kV. Here we are having one 110 kV outgoing line, and here we are also having two transformers with 110 kV at the primary side. Let us start with the transformer 110 kV, 110 kV. First one is 15 MVA, 3 phase. You can see 3 phase. First one is one transformer. MVA 110 kV slash 66 kV. Okay, and that quantity is two numbers, so mark two transformers 110 kV or 66 kV. So we marked 110 kV bar 66 kV, two transformer. After that we are having one more 110 kV bar 11 kV, that is 10 MVA. And so it is also a three phase. We'll consider it here. One 10 kV bar 11 kV. It is 10 MVA. Here it is 15 MVA. Okay, and we are having one more transformer. You can see that one more transformer is 11 kV. Since we haven't come across the 11 kV bus bar, we can't take this transformer yet. Okay, after that we can move. You can see here we are having a 66 kV line. Here is also a 66 kV line, and here we got a 11 kV line, and we can see here we got a 66 kV bus bar, 66 kV line. We can use these two lines to connect with our 66 kV bus bar. Here they had mentioned only one bus bar of 66 kV, 66 kV bus bar. 66 kV was the outgoing from the transformer secondary, so we attached our 66 kV bus bar to the 66 kV line. And here it is 11 kV, and we are having one bus bar with 11 kV. You can use that to attach here. Just be aware, we are attaching with the similar voltages. 11 kV was the secondary voltage, and here it is 11 kV bus bar, 11 kV bus bar. Okay, after that we are having one more bus bar with 400 volt. Since we haven't come across any 400 volt line, we can't draw the bus bar yet. And here you can see now we are having 11 bar 400 kV transformer. Let us see, do we have any 11 kV bus bar here? Yes, we are having one 11 kV bus bar. We can use this transformer, can use this 3 MVA 11 bar 400 volt bus bar to this line. Okay, let us connect this transformer. It's also 3 phase transformer. Connect this 3 phase transformer, which is 11 kV bar 400 volt. Okay, now we draw all the 4 transformer. 2 plus 1 plus 1, 1, 2, 3, 4. 4 transformers are complete. Now we can see, and the number of bus bars 110 kV 2, after that 66 kV 1, after that 11 kV 1, and we left with 400 volt. Do we have 400 volt line now? Yes, we are having a 400 volt line. We can use this bus bar now. 400 volt bus bar. Now we got all the parameters, all the bus bars and transformers. We got the 2 incoming lines You can see only thing left is the outgoing lines. Now we can draw the outgoing lines. First outgoing line is 110 kV 50 hertz. You can see 110 kV 50 hertz, one outgoing line. So 110 kV outgoing line can be taken from the 110 kV bus bar itself, not from anywhere else. So this 110 kV 50 hertz is taken from the 110 kV bus bar. You can see 110 kV 50 hertz bus bar. Now I am going to mark it as 110 kV 50 hertz outgoing. These are incoming. These are incoming, and here it is the outgoing line. Okay, first outgoing line is complete, and second outgoing line is 66 kV 50 hertz, one outgoing. You can see 66 kV 50 hertz, one outgoing. You can draw the outgoing line to the bus bar itself. 66 kV bus bar is here, so we are marking it as 66 kV 50 hertz outgoing. After that 11 kV 50 hertz, one outgoing line. Outgoing line is marked to the bus bar only. Here is our 11 kV bus bar. We'll mark it here, outgoing line 11 kV 50 hertz outgoing. Okay, you can see this. Okay, now we got three outgoing lines. First outgoing line was 11 kV 50 hertz, second one was 66 kV 50 hertz outgoing, and third one was 11 kV 50 hertz outgoing. Now we got a draft of these things. Okay, here you can see this is a draft of the single line diagram. We got two incoming lines. We got 4 transformer as per the requirement, and we got 3 outgoing lines. Okay, and we got 4 bus bar, 110 kV bus bar 2 quantity, 66 kV bus bar 1 quantity, 11 kV bus bar 1 quantity, and 400 volt bus bar 1 quantity. Now to any substation, since it is a generating station, you can see since it is a generating station, for any station we'll be having a few more equipments. Okay, precautionary or safety equipments will be there, like current transformer, potential transformers, okay, lightning arrestor, earth switch. As we discussed in our previous video, we'll be having components. We need to place the components wherever necessary. Okay, to complete this diagram, okay, we'll have this one. Okay, here you can see the complete single line diagram. Hope you all can see it clearly. The same problem as we discussed here, I wrote it earlier itself. 2 incoming lines, 110 kV 110 kV, and here we got incoming line 1 and incoming line 2 having 110 kV value. Okay, we got 110 kV value, and we got 110 kV bus bar 2 quantity. You can see 110 kV bus bar 2 quantity. After that transformers 1 2 3 transformer, and here we got one more transformer. Okay, after that outgoing lines 1 2 3 outgoing lines. Okay, 66 kV, 110 kV, and 11 kV. Okay, these are all the components that we are going to use here. Okay, let us start with the basic precautionary measures that we are going to use. Okay, for any substation, okay, or a generating station or distribution station. First equipment that is coming to the picture will be the lightning arrestor entering to the substation. Okay, the first component is lightning arrestor. Okay, lightning arrestor. After that CT, remember. After that PT. In between CT and PT we'll be having a circuit breaker, a smiley, you can see. First component is lightning arrestor, second component is CT, third, and after that PT. In between CT and PT we'll be having a circuit breaker CB. Here it is LA, lightning arrestor. Okay, before the bus bar we'll be having the isolators I. Okay, we'll be having the isolators I. Similar to the first incoming line, we'll be having the same components at the second incoming line. First one is lightning arrestor LA. Lightning arrestor is grounded, you can see. After that CT. After that circuit breaker CB. After that PT and isolator I. Okay, these are the basic necessary equipments. After that these two bus bar will be connected by an isolator switches. The opening and closing of isolators can use. Okay, the connection to the incoming lines are taken from here, so that if one bus bar fails, you can use the other bus bar for connection. Okay, after that we'll come to the heart of the substation or generating station, that is a transformer, which is the costliest equipment on a station. Okay, after the bus bar we'll be using an isolator. Remember, entering the bus bar and leaving the bus bar we'll be having isolators for all the lines. Okay, we'll be using isolators I. Mark it as I. After that circuit breaker. Before the transformer, circuit breaker, a PT, potential transformer, okay, and a CT, PT and CB, circuit breaker near to the transformer. Again after the transformer, CT, PT, okay. Before and after the transformer we are going to use the CT and PT, one circuit breaker to the line. After that near to the bus bar, as I said, isolator. Okay, similarly for the next transformer also. Before the transformer, PT and CT. Here also PT and CT. After the bus bar, isolator. Before the bus bar, isolator. Okay, and one CB for that line. For this line also one circuit breaker, and here also one circuit breaker. Similarly for third transformer, one CB, PT, CT, again CT and PT. You can see the potential transformers are always grounded, similar to our lightning arrestor. Okay, and we got one more transformer here. For this also, sorry, here we left an isolator before the bus bar, isolator, and again after the bus bar one isolator. Now we got transformer. Before transformer, for this line we are having one CB, PT, here it is CB, PT, and CT. Again here also CT, PT. PT is always grounded. Before the bus bar, one isolator. Okay. Now we got the incoming lines and the transformers and the bus bars. Now we are left with the outgoing line. The outgoing line should also be protected. You can see outgoing lines are always connected to the bus bar. After the bus bar, an isolator, one CB, PT, CT, and a lightning arrestor, LA. Okay. Bus bar outgoing line is connected with a circuit breaker, PT, CT, lightning arrestor. Similarly, all the outgoing line, isolator, CB, isolator, CB, PT, CT, and a lightning arrestor, LA. Similarly here also, after the bus bar, isolator, CB, PT, CT, and lightning arrestor. This completes the single line diagram. You can see two incoming lines, 4 bus bar, 2 number of 110 kV, 1 number of 66 kV, 11 kV 1 bus bar, 400 volt 1 bus bar. You'll be doubting, what if they haven't mentioned the bus bar, sir? If they haven't mentioned the bus bar, remember, above 66 kV we prefer a double bus bar, below 66 kV we prefer a single bus bar. That would be better for drawing a single line diagram. Okay. Below 66 kV single bus bar, above 66 kV double bus bar would be preferable. Okay. This completes the single line diagram for this specific problem. Okay. And here we got the problem. You can recall it. Thank you. We'll catch up in our next video.